Swayam Prabha. Digital India. Educated India.
We now are moving towards the student project as usual. This is your sixth session, and we've had how many? About five student projects already, right? So it's nice. It's nice to know that there is someone who you can actually imitate. Have I used the right word? Imitate, because the student doing the student project serves several purposes. One of them, of course, is knowing how they did it, so you become better at the process. The second is to take inspiration from that person and say, "Oh, this person has done it, I can do a similar way." The third is, if you're an entrepreneur, try and find out if that idea appeals to you. Then you can find out if you can collaborate with the person who brought out that idea and do something to make that idea happen. And the fourth thing, of course, it gives you tremendous confidence in creative thinking, because you know that when you go from problem to solution, you can, and you actually come out with some tangible solution which can be implemented. The confidence in your own ability to think through a problem, come to a solution is tremendous. Nothing can beat that. So now I'm going to go to the student project. The name of the student is Sahana Gangadharan from IIT Madras, and what do you think she would have done first? She would have chosen a United Nations Sustainable Development Goal. So now the goal that she's chosen is goal number 6, clean water and sanitation. So clean water and sanitation, there's apparently an emotional connect for her to clean water and sanitation, which is why she chose it. So this is the target selected. Now all this is very familiar to you. I think if I wake you up in your sleep and ask you what's the next step, each one of you will say it, right? And that's how familiar you must be. So the targets and indicators that she selected, all of them are there. So her goal is clean water and sanitation, ensure access to water and sanitation for all. The targets selected are, again, this is, so therefore, target selected 6.2, 6.3 indicators, and 6.B and 6.3. These are the targets she selected. Apparently, she's done a lot of work reading up on the goal, which is what everyone must do. Remember the connection between information and new ideas? Don't forget that, please. Then what does she do? She looks at the process, the spiral, and what does the spiral say first? Is to define the problem. I'm not going to get into detail because I want you to read Sahana's notes, Sahana's PPT. But just to guide you through the PPT, what we are doing is she's asking the question, how might we design facilities to ensure safer sewage management? So therefore she is saying, how might we design facilities to ensure safer? So her objective is safer sewage management. So why is it an important problem? I don't think anyone needs to argue saying it's not an important problem, and she's got enough reasons to say that it's an important problem. Next is biologize. Biologize, like we said, remember, ad nauseum to repeat doesn't matter. Ad nauseum to think that, to understand that biologize means asking the question, how does nature accomplish what I want to accomplish? In this case, what are the three functions that emerge out of the problem statement? The three functions in the problem statement are manage sewage, treat waste, and clean water. Clean water as in, clean here is a verb, clean water, not the noun, clean water. So manage sewage, treat waste, and clean water. And you will find that all the three functions have a verb in them, which is an important aspect of a function. So therefore, the question that she asks, how does nature manage waste? It's so simple, falls in so logically now. So imagine the more important thing is your skill in finding out what is the function that you want to accomplish. How does nature ensure sanitation? How does nature clean water? Right? What has she done? She's gone to discover naturally, and there she's spoken about something called eco machines. She's described eco machines and she's spoken about eco machines. Look at the last paragraph. They move water using dendritic principles, several interconnected cells. So, when I read Sahana's project for the first time, I knew there was something about lot of interconnections, water having to go through several filters. That's what I understood the minute I saw that, and that's what I think she's trying to convey. And then what does she say? She looks at the kidney. I think very rare. Normally, one would look at outside the body to look at organisms. Here she's saying, let me look at my own kidney. And what does she find? That the kidneys purify blood, purifies blood, maintains electrolyte concentration, captures. Look at that same thing. It's coming back. The idea is coming back to captures, absorbs, filters water. And she goes on to looking at the kidney and all that. You can read all these descriptions on your own. Otherwise, you'll get bored if I keep on reading it line by line. So here she's actually talked about something called biolytics water filter. If you look at the second paragraph, you will understand why she's talking about it. She's saying treatment of sewage, how forest litter decomposes, insects, microbes convert waste and humus into humus, which acts as a filter. So here she's talking about several organisms that filter waste, and she describes what is called a biolytics water filter. So how I interpret it is because what I learned from Sahana is that if I read about the water filter, I understand what nature does. So this is her discover. The next one is abstract. So how do I translate the biological strategy to a design strategy? So she is abstracted design strategy. She's made some drawings, very clear. You look at this paragraph, or you'll start to understand how easy she's made the process of filtration. And she's done one more abstract to explain it even more deeply. How interacting organisms in the ecosystem filter waste. So her whole thing is about filtering, interacting organisms, etc., etc. Again, she's done one more abstract, made it even more simple. She's actually drawn pictures to help us understand what she has in mind. How does nature accomplish the function that she wants to accomplish? How does nature clean water, etc.? So there's one nice word here called stepwise architecture of ecosystems. Maybe you can Google that. Then she does emulate. You know, emulate is idea. So here she's got an emulate idea. How do I apply the bio-inspired strategy to the problem I wish to address? So please read it. I'm going to give you can pause the video now and read how she does the emulate. And if you have some questions on this, you can use the live sessions for the questions, or you can write to us and ask some questions about this idea if you're interested in this idea. Again, she's made it, her idea is going towards, I think, having beds. I think, as we will see, she's having some beds to make the water filter from one bed to the other bed and all that. And finally, of course, she's talking about evaluate. So from emulate, so therefore her emulate idea is suburban wastewater management system design. She has written down the design. The system design is hierarchy and works by filtering waste materials in every level. So every level is being filtered. Each compartment has two sections to employ a separation. So she's employing separation using osmotic pressure difference. A pressure-inducing pitch is instilled on the left and on the left end to speed up the above process. Right? Pressure-inducing patch. The cross-section of pipes that connect every compartment has intricate internal structure that enables to absorb nutrients, This multi-layer design, albeit slow, is economical and filters nutrient-rich water from sewage effectively. So this is her system that she's created. And from her idea of a system, she's gone on to evaluate. How can my solution be applied in the real world? How will I follow nature's design principles? So she's saying nature recycles all materials, so she's followed that principles. Nature uses chemistry and materials that are safe for living beings. In her design, she is not using anything toxic or unsafe. So what are the next steps that she wants to do? Identify materials required, ensure the working of a single compartment before deploying the entire system. It's a very clever way of doing it. And treat the final output stream with water softener to make it fit for drinking. So water softener, I'm sure, is going to be non-toxic. And finally, she's created a water filtration system simply because she intended to do it. So the cornerstone of creative thinking is intention or willingness to be creative. By showing us these student projects, we are hoping that we are making more and more of you willing to be creative.